Hello. Gotta turn on my lights here in my studio. The room in my basement. That's my room of requirement. It is whatever I want it to be. Well, hello everybody. Did you did you guys enjoy? Did you enjoy? Are you enjoying the election as it unfolds? Isn't this crazy? This happens over and over and over again. So, who was the biggest loser? Again, I guess this is the second presidential election in a row. The biggest loser? The polls. The polls were so wrong. So I guess we have two presidents for a little while. We simultaneously have two different presidents, and it'll get sorted out eventually. And you know what? The election turnout is, I think it's the highest turnout of all time, which is pretty impressive. You know, people may be very polarized, but we're also very engaged in the political process. At least we're getting out and voting. It's fun. It's fun. So I had a thought. I'll share this with you at the end. I had a thought about the. It's a little scary thought about, you know, the fact that these national elections over and over again are so close, even though, you know, the polls say whatever they are, but these elections are so close. I have a theory about that, and it's a little disturbing. So if we have time at the end, I'll share it with you. So it has to do with artificial intelligence, our overlord of the future, or has it already happened? Okay, so let's do some GIS. We have a practical exam tomorrow, and I want to field questions from you today. So the practical exam, maybe that's not the best word, task, performance assessment has been posted for a long time, and but if you guys have any questions, put them in the chat window, and I'll hopefully see them and I can address some of the questions. But I want to pick up where we were last time. We were I was going through the process of answering a question, which was a hypothetical end of semester project that I posed. This idea of is there a relationship between the locations of these petrochemical plants in Louisiana, which are emitting in some cases large quantities of chloroprene, which is a precursor of neoprene, and is a carcinogen, and if there's a connection between these releases and cancer rates in the vicinity. So we were I've been having some tech problems today. It's a good thing I don't have to count any votes. I've been having lots of tech problems. All right, I'm zoomed in here to West Virginia, but we got to this point last time where I'm going to close that. That's something different. Pay no attention to that. You do not see that. We found some data on the internet from the toxic release inventory, and that database is amazing in that you can find these sources and sort by specific chemicals. So we sorted by chloroprene, and then in Louisiana, and when we exported this data, you can also pull along with it the latitude and longitude of these facilities. And you know, obviously these release facilities are not on equal footing. You know, we probably don't even want to include those two, but let's include them all for right now, okay? I mean, this is so much larger than the rest. We could even like focus on that one facility. It's a factor of like 35 larger emitter of this chemical chloroprene. Okay, so then the next thing we need to have cancer data for Louisiana, and we can find that from let's see here. Oh, I have Earth Engine still open. All right, bear with me. See, I told you there we go. Having tech issues. And okay, so I found some data from, let's see if I can remember, cancer rates, Louisiana. Let's see what we come up with. Cancer statistics. Maybe I'll try this. County cancer rates, United States. Here we go. Cancer data and statistics tools. So where did I find this? So this is CDC, another government agency with just tons of data on a whole bunch of different topics. This CDC Wonder database, I've used this in the past to get data on opioid related mortalities, and it's let's take a look at let's try that. State cancer profiles. This doesn't look familiar to me. I just did this. Area type by county. Oh, you can get by health service area. Let's do by county. All cancer. All races. Both sexes. All ages. Okay. So I can export this data. Okay. So so I got data that I didn't get it here. I got it somewhere else, but I could export this data. These first two rows are totals for Louisiana and then the U.S. And you see that this data is organized by parish, which is the Louisiana version of counties. And there's some other data in here. I don't. Which year is this? This is from 2013-17. So I got this data. It wasn't from this particular source, but it's identical. Here, let's see if I can find it. Where is it? I had it on my desktop. There we go. Okay. So I found this data, and remember we were talking about this problem? It's got all these parentheses around it, or apostrophes around the data. I don't know if you can see that. It's very tiny on your screen, I'm sure. Let's make it larger. Here we go. So we gotta peel away all of those apostrophes, which could be a real pain in the butt. But this is Excel, so let's use a built-in function for that. And I think I know exactly the one to use. I know exactly the one to use. I think there's a function called mid, and it'll return the middle. So we'll start with the second character, not the first, and we'll go to the length of that thing minus, I think we'll have to do -2. Let's see if this works. Yeah, that worked. So that just takes out the middle of, the text in this cell is apostrophe, Louisiana apostrophe. So I just pulled out the middle. And if I come across and then fill down, it should do all of it for me. Great. Okay. And then I'll just copy that and just paste it back over here. Just overwrite this, and I'll do a paste. Oh, hold on, that didn't work. Let's do this. Copy, paste values. Just paste the values in here. There we go. And then I'll just delete all this extra stuff that we got. Okay, so I've succeeded in peeling out those extra apostrophes. Okay, so now I have this data set. I'll call it, it's from the U.S. Cancer Service. I think that's what that stands for. Louisiana Cancer. Let's do counties. Okay. All right, so you guys, I can pull that into my map now, and let's take a look. Okay, so this is not a feature layer yet. Okay. I want to map this cancer data to a map that contains polygons for Louisiana. And so the first thing I need are polygons for the counties of Louisiana, or excuse me, the parishes of Louisiana. And I can totally do that. I just got to go and find this data. And I know that it's out there on ArcGIS Online. It's in the Living Atlas. It's USA Counties. I know it's in there. I don't know what the difference is between counties and generalized. Let's just do this one. Adding it. Boom. There it is. Okay. So let's do a select by location. We're going to select. Nope, sorry. Select by attribute. We're going to select the counties where the state is equal to. I could also do a definition query here. All right, so you guys, you know, one thing that while I'm thinking about this, you know, when I've been talking to some of you about the practical exam, and one thing that I think everyone I talked to so far has not done this. So one of the feature classes that I gave you is a polygon that gives you an outline of the 48 contiguous United States. And if you read my question carefully about the national parks and the cities with 20,000 plus, you know, I think you guys know that you got to do a select by attribute or a definition query to peel away the cities that have 20,000 or more people. All right, you can do that. But you also need to peel away the national parks that are only in these 48 states. And there's national parks that are in Alaska. There's at least one national park in Hawaii. There's even I think there's a national park in the Virgin Islands. So you got to peel them away. So you're going to have to do a select by location using this polygon I gave you for the United States, 48 contiguous United States, to select out and then create a feature class from that selection. Just the national parks that are in the 48. Otherwise, you might be able to figure out the correct answer, but it won't be obvious from the results. In other words, it won't be. You'll have to do some sort of when I look at your attribute table, I'll have to you'll have to peel away values that aren't valid when that should already be done. Okay. All right, so back to here, we want the state equal to Louisiana. Okay, and now I will export, or I could use, let's use the geoprocessing tool. copy features. The input features are the selected counties here, and then the output features will be called Louisiana. Counties. And I'll run that. All right. So that was quick. Now I'll delete that remotely hosted feature layer, and I have this new feature layer in my database, Louisiana counties. Okay. So if we look at this attribute table, uh-oh. I can't use this because there's no way. Wait a minute. How is the county name not part of this feature layer? All right, let me try that again. Oops. Let's try this one. Okay, we got county names. All right, let me remove that. So, that's weird. It's not like showing up on the map. Okay. There we go. Oh shoot, I forgot to do the selection. Why did you guys tell me? I forgot to do the selection. Select by, not location. I forgot to do select by attribute. State name is equal to Louisiana. Okay. All right. Get those out of here, and I'll remove that. Okay, so let's take a look at the attribute table now. Yay! All right. So what the thing that was missing is I used that that other hosted feature class, a hosted layer up there that had the counties of the United States, but it didn't have a column for county name. Do you guys know why I need the column for county name? Anybody know? Let's take a look. So we got, yeah, Cam's got it, to join. So we're going to have to do a join to join the cancer data to the county's polygons. So one thing is the names aren't quite the same. You know, we got Cameron, Beauregard. Can't even say half of these. Oh man. And but in this, all the counties have parish after them. So that's not actually that hard to fix. I think I can do this in a couple steps. Let's go over here to the attribute table and let's add a field. And we'll call this field just parish name. And it'll be of text kind, data type. There we go. And then I'll save this. and close that. And so now I have a parish name field with nothing in it, and I'm going to make this a calculated field. And what is this going to be? It's going to be, let's see if I can remember how to do this. It's going to be the county name plus a space, and the word parish. Okay, let's see if this works. Apply. Bingo! So Ascension became Ascension Parish. Livingston became Livingston Parish. So now I have a column in this attribute table that matches up with a column in this this table. So now I can do a join. Oh, there it is. Joins and relates. Add a join to the input table is USCS Louisiana counties. Whoops. The input field is not county name, parish name. Louisiana counties, parish name. The join table, the table we're joining is right here, USCS Louisiana counties. And the field is in here, county name. Keep all target features. Sure. Let's validate, make sure. Succeeded. Good. Okay, it's gonna work. It's gonna work. Yay! That was quick. All right. Close this up. And so now if I scroll over here, there it is. There's the cancer rate and the case count. All right. So now I can do some symbology here to instead of doing single symbol, do like graduated colors, where the color is related to one of these. Let's do, I guess, age-adjusted rate will be the right one to do. And natural breaks. Okay, all right, we'll save that. So zoom in here. Okay. Well, blue means there's a higher age adjustment. This is all cancer types too, so we're not looking at any particular cancer type. We might have to do some more research to figure out, like, is this chloroprene ostensibly linked to a specific kind of cancer? That could very well be the case. So here we're just looking at cancer, all cancer types. So it looks like, in this area right here, you got some blue, heavier blues. Here, not so much. So maybe we will. Let's see, where is this one? Oh. Attribute table. Let's see. So these small emitters, and that one's over here. What about this one? I think I'm going to get rid of this one because it's so small. It doesn't really compare, and I think I'll get rid of this one too. So just delete those rows. So we got these three locations over here. And just out of curiosity, which one is this one? Right here. So we got, okay. Was that valid to just delete those points? I think so, since they were like, a factor of 20 less than these other sites. Okay, so now what? Anybody have any ideas? Let's keep our eyes on the prize here. We want to quantify, let me clear the selection. We want to try to see if there's a difference between the cancer rate, adjusted rate, we're just focusing on adjusted rate, for cancers, all cancer types in the vicinity of these plants compared to the statewide. So what should I do? Anybody have any ideas? What should I do? So maybe back up here a second. The requirement that CAM says kernel density. So kernel density is a really good way to summarize point data. So if you have lots of points, it can figure out how densely packed those points are. Find clusters, and you could have cancer data that's like that. You could have like a pinpoint on your map for like every cancer case, showing where it's located. And here our data does not exist in that format. It exists as, so age-adjusted rates are already normalized by population. So it's total number of cases divided by total population. And age-adjusted means that they're taking into account that the demographic profile of these different counties may not be the same. So it's sort of normalizing over the demographic distribution. So kernel density isn't the way to go here. The requirement that I'm putting on you guys for the final project is you got to use 2 analysis tools. Okay, so if you think about the question here, the question is about, are cancers near these locations, these plants, more prevalent than they are globally in the entire state? Okay, so think about tools that that allow you to define define the space in the vicinity of a point. We want to know if cancers in the vicinity here are more prevalent than cancers globally. What do you think? Nobody's thinking today. Yeah. Well, all right, so let me ask you a question that's related to the practical exam that you're going to take tomorrow. So counting cancer cases is similar to counting people in the vicinity. So, one of the tasks I have set before you for tomorrow is to estimate how many people live within 50 miles of the Appalachian Trail. So, what I'm asking here is not that different. I'm asking you how many cancers are within a certain distance of these petrochemical plants. So, what do you think? Buffer. Cam says buffer. Okay, so we can buffer these points, and then we can sum up the total cancer cases. I guess we could go a number of routes. We could say, what's the average? Maybe we'll do this both ways. The average age-adjusted rate in this buffer, and we could say, what is the total number of cancer cases? What's the total population? Take the difference to give you the sort of raw cancer rate without doing age adjustment. So I think we can do it both ways. There's probably something more sophisticated we can do. But this will give us an idea and give us something close to the actual answer. So, you know, if you guys were setting this up for your final project, you would, you know, I want you guys to use Model Builder to create a tool, and the buffer size could be a parameter in that model. All right, so let's do it, and then we can do the Model Builder stuff next time. All right, back to work. Here we go. So, close this. We got our chloroprene emitters, our major chloroprene emitters, and our Louisiana counties, which age-adjusted rate visualized here. And let's search for the buffer tool. And our input features are the emitter sites, and our outputs are the buffer. So we got to decide on a distance. It's a parameter in a model. Let's just do we'll try 20 miles. And actually, in the output, we only need one feature because we're interested in what's in that entire buffer. So we can dissolve all output features into a single feature. And I'll run it. Okay. So now we got these buffers. Notice that they're kind of squished. That's from our projection. I use geodesic shape preserving buffers. So 20 miles this direction is 20 miles this direction, and it's squished because of my map projection here. All right. So now I want to tabulate the cancers in these buffers, and my favorite tool for doing that is, it'll be interesting to go through all the different ways you can accomplish this, but my favorite tool is Summarize Within. And so my input polygons are the buffers. The summary features are going to be values that are in the Louisiana counties, and we'll create buffers summarized within as output. Keep all input polygons. There's only one. Now down here in my summary fields, this is where things get interesting. So what I'll do is I'm going to do the average or mean of the age-adjusted rate in this buffer. Okay, so this one right here, this polygon has a lower rate, this one has a higher rate, this one has a lower rate. So I'm gonna average them, and it's gonna do you know, so this value is gonna matter. The value of this polygon is gonna matter more than the value of this polygon in that average. It's like a weighted average, because more of this polygon is inside that buffer. And then for these other things, case count, I'm gonna want to sum it up. And population, I'm going to want to sum that up, okay, because I want total population. Add summary shape attributes, square kilometers. Sure, we could do, well, square miles. You could calculate then cases per square mile, which might be interesting. Okay, so when this is done, it'll create a new feature here. It's working. Uh-oh. Something unexpected caused the tool to fail. Contact Esri technical support. Oh, okay. Let's try. Okay, well, that's weird. Let's turn this off. Maybe that was the error. It's being edited with the application. Come on, Esri. You gotta get some of these bugs worked out. And I'm totally blaming Esri. All right, well, let me save my project. Save all edits. Oh, maybe that's why I didn't delete those things. Oops, I just opened the wrong project. Bear with me. Here we go. All right. So we'll try that again. All right. So let's summarize within. Yeah, okay. My input polygons are these buffers that I've created. My summary features is data inside the Louisiana stuff. Look at that. It created it's creating a new. I wonder if it created a feature class. It just didn't add to my map. Whatever. I'm gonna delete that and try it again. Let's keep the one there. Keep all input polygons. Okay. We're gonna do the mean of the adjusted rate, the case count sum. So you guys know how to set this up for your task tomorrow? You're going to have population values. Which one of these are you going to calculate? What the heck? We'll do square miles. And is it going to work this time? Come on, baby. You can do it. You can do it. It's writing feature. Yay! Woohoo! Alright. It's good when you don't get unknown errors. Alright, so we look at the attribute table. Remember we dissolved all those polygons into one feature? That's why there's only one row here. And summarized area in square miles. So this represents 3,153 square miles. Is that what you get if you... Well, I guess we can't do this because these overlap. I was thinking you take 3 circles and of 20-mile radius. So these are the case counts, population, and the age-adjusted rate. So let's add a field here, just out of curiosity, and let's see what the raw rate is. So we'll do raw cancer rate, and I'll save that long. That's fine. And so we're going to calculate that column. It'll be a calculated column, and it's going to be equal to the where is it? Case count divided by population. And so this is going to be a really small number because these adjusted rates are, I believe, rates per 100,000. So we want to actually take this second value. Well, I guess another way to do this is multiplied by 100,000. Okay, and let's apply this. Alright, so that's interesting. So the age-adjusted rate and the raw rate, they're close but not the same. So the age-adjusted rate is taking into account that the demographics aren't the same in each of these different counties. Alright, so what remains is for us to calculate so we have now statistics for inside these buffers, but we want to compare them to the statistics for the whole state. So what remains is to calculate those statistics, and we can do that. Analysis. Why Am I blanking? Map. I'm totally blanking. There it is. Summary. Oh, come on. All right, there we go. Summary statistics. Okay, so this will create a table output, and our input's going to be the Louisiana counties. So the output will be Louisiana County statistics, and the fields here we can do, and this the same thing. We can do a mean of the age-adjusted rate, the sum of case count, and the sum of population, and then run that. And see, it created a table down here. Let's open this and take a look. Okay, so here's the mean, and so there is a difference. Is it statistically significant? Well, we'd have to do more work for that. So the age-adjusted rate inside our polygons is 488, 489, and for the Louisiana average, it's 483 total. We could do, let's add a raw cancer rate field as well. Calculate field. So it's 100,000 times case count divided by population. Okay, 536. That's interesting. The raw cancer rate in Louisiana is higher than the raw cancer rate inside these buffers. The age-adjusted cancer rate is a little bit lower outside of the buffers compared to inside the buffers. Okay. So anyways, do we have an answer? Do we have an answer to our question? Are cancers more prevalent in the vicinity of these chloroprene? We don't have an answer. We have some data that says that well, based on one statistic, yes, but we don't know if it's the statistically significant difference. And based on another statistic, no, the cancer rates are less. So we would really have to do some more careful analysis here. Maybe break the cancer data down into smaller chunks instead of county levels. Maybe we can find like census tract data, cancers by census tract. And we need to do a little looking to see if there's a specific type of cancer that's a concern. All right, but if anything, we get that a picture that or a result that says the picture is more complicated than maybe it seems to be. That there's more, I know for a long time I've known that this area of the country is called Cancer Alley, and the analysis we just did doesn't really bear that out, but we're probably missing stuff. We're probably, there's things about this area that we're not including and data that we're not looking at in quite the same way we should. Okay. But for the purposes of my hypothetical project, I've accomplished my goal. The answer to my question would be inconclusive, or the data doesn't show any major difference. Or I could just say, well, there's a little difference, but we don't know if it's statistically significant. There's lots of ways I could present that. But you have data, you have calculations, you could present that data, and write up the one-page summary that describes it. So on Friday, we'll focus on making the model builder for this analysis because that's part of your final project. But tomorrow, Alexis has a question about the practical. When we do graduated color symbology for the national parks, does it matter what interval method is used? No. Pick something that looks nice, okay? It doesn't matter if you do natural breaks, manual interval. You want something that gets, so the message that you're communicating is that some national parks are more isolated than others. So just pick values, pick a number of classes that gets that message across. And if it gets that message across and looks nice, I'm gonna love it. All right. So I'll see you guys tomorrow. If you haven't already signed up for a time, please do so. I haven't gotten any emails about people who can't make it, so I'm expecting everyone to be able to come in during one of those 3 time blocks. And if you have a really good reason why you can't, then let me know so we can deal with that. All right. Alexis had a question yesterday, and this applies to some of you other students as well. She uses her laptop in the lab to do the lab activities, and she said, "Can I use my laptop for the practical?" And I said, "Yes, you can." Her concern was, well, how am I going to share my project package at the end? Once you're done, you're going to package up your project, and I said you're going to drop it on the Dropbox in lab. There's a couple ways around this. You could email it to me using WeTransfer, which allows you to send huge data files up to like a gigabyte in size. It's a free service, WeTransfer.com, I think is the URL. You could put it on a flash drive and just hand it to me, and I can transfer it that way manually in lab. That's probably the easiest way. Emailing it to me won't be an option though, because it's going to be like, these files are going to be like 60 megabytes or larger. So we'll do one of those. All right, just if you're using your own laptop, we'll figure it out. But if you remember, bring a flash drive with you. That'll probably be the easiest way. I'll try to remember to bring one too that we can use. All right. That's all. So I had on the description of the lecture today that we were going to look at land cover data sources. We will do that Friday for sure, and this might be of use for some of you for your final project. This came up yesterday because I was talking to Tyler about his project, and he was interested in impervious surfaces near Hagerstown. So there's publicly available data that you can get, and I'll show you some of that and how to put it into your project. All right. Well, enjoy the dramatic 3-month conclusion to the 2020 presidential election. It might actually be that long. We'll see. And in the meantime, two presidents are better than one, right? All right, I'll see you guys tomorrow.